Today's class we would discuss about Anova. So what is Anova? Anova is simply written as ANOVA. Anova means analysis of variance. We are measuring the variation within the data set. So for this variation we are keeping a reference point as mean, right? So this is the mean of the data set. Now variation has to be in reference to the mean difference. So this is variable and this is the mean. So mean difference is noticed like that, and then we will note down the sum of the squares of the variable. Now the question of variation is there. Now variation will arise within the group and variation will arise between the group, right? So we will demonstrate using student example of this Anova, right? So let's start. Variation within the group. Now we have three groups and each of them they are trying to get leverage with other, right? The difference between these is called the variation within the group, right? Between the group. There are three groups, first, second, third. Each group is having variation. This the movement shows the variation within the group, right? So we have to measure within the group and this is the between the group, right? Sum of squares between the group is very difficult to calculate here. It is very lengthy because there is no fixed mean. So what we are doing is we will arrange all the data set in one row. Right? Now the arrangement works like this. Now this is called the total variation, right? All the groups they are arranged, all the data set they are arranged, all the students they are arranged in a single group. So total variation can be covered with respect to one mean. In order to find the variation between the group, the formula is given as total variation is given in the group is variation between the group and variation within the group. So this is demonstrated using students. So a three group of data. This is the first x variable and we have values of 3, 2 and 1 as it was earlier, right? Next we have the second group as y and y has value of 5, 3 and 4, right? And similarly this is the third group that is having the z value and z is having value 5, 6 and 7. Right? So these are the variables which are there. These are the total variables. Now the mean of this. Now mean of x, if I sum total x value, where is x? The sum total of 3, 2, 1 is 2. So the mean value is 2. Similarly for y value, the sum of 5, 3 and 4 is 4. The total value of mean is 4. Here for the z values, the mean value is 6 if I total it, right? So this is the observation of this data set, right? Now we are interested in deviation. This is the positive deviation, x minus x bar whole square. The positive deviation value with respect to mean is 1, 0, 1 for the x group. Now similarly for the y group, y minus y bar whole square is 1, 1 and 0, right? For the third group, that is the z group, z minus z bar whole square is 1, 0, 1, right? Now let us see what is the summation value of each. Now the summation, total summation of this x group is summation square is 2. right? For the y group, the summation square is 2 if I sum all the values. Now similarly, if I sum the z values, the summation square is 2. So the total sum of square SST will be this value, and this value. Total value will be 6. 2 plus 2 plus 2, 6. Sum square total will be 6, right? Now concept of degree of freedom. Degree of freedom covers the variation, total variations, right? It accounts for the variation. It is usually given as n minus 1. Now there are 3 possibilities. Degree of freedom total, when you are standing in one row, so that is called degree of freedom of total, right? Next is degree of freedom of numerator, right? Degree of freedom of numerator is total group minus 1. So we have 1, 2, 3 groups. 3 minus 1 will be 2, right? And we have degree of freedom of denominator. Degree of freedom of denominator will be calculated out of total observation. So I have 9 students, right? 9 minus 1 will be 8. So degree of freedom total will be 8 for this observation, and if I subtract 2 out of this 2, that will degree of freedom of denominator will be 6, right? So now on to the calculation board itself. I have arranged the students, since you have seen I have arranged the student in one line. So these are the xi values, and the total mean is 4, right? So these are the deviation from the mean, and this is the deviation squared from the mean. So sum squared total for all this observation is 30. Now these are the values of x, 3 to 1, and this mean is 2. Similarly, the second row y has 5, 3, 4, and mean value is 4. Now third row is 5, 6, 7, and the mean value of z row is 6. So these are the deviation squared, and the sum of the deviation squared for x value is 2. Similarly, sum of the deviation squared for y value is 2. Similarly, sum of the deviation of z value is 2. Now sum square within the group is summation of sum squared variation between x, y, and z. Now total value sum square within will be then 2 plus 2 plus 2 is equal to 6. So sum square within is 6. Now on to the next stage of the calculation. In the next stage of calculation, we calculate the sum square total value which was calculated, and then it is equal to sum square between and sum square within. So all of you have seen the sum square total is 30, and we need to find this sum square between. For that we add this with sum square within. So sum square within is 6. So sum square between will be 30 minus 6 is 24. Now regarding the degree of freedom, I have already told you total degree of freedom will be total of number of observation minus 1. So there were 9 students. 9 minus 1 will be 8. I have already mentioned will be equal, this degree of freedom total will be equal to degree of freedom of numerator plus degree of freedom of denominator. Now I have written this as small dft is equal to dfn plus dfd. I have written. Now total degree of freedom is 8, and degree of freedom for numerator, that is number of group minus 1 is 2. So similarly we can find degree of freedom of denominator will be 8 minus 2 is equal to 6. Now on to the f-test calculation value. F-test calculation for degree of freedom, given degree of freedom of numerator and given degree of freedom of denominator is given as mean square between and mean square within. So for mean square between calculation, we use sum square total between the group and degree of freedom of numerator we have we will divide by that. So it was value was 24 and 24 divided by 2 is 12. Similarly, we have to calculate the variation within the group. So for that, mean square variation within the group is given as sum square within the group and divided by degree of freedom of denominator. So it was the sum square within total was 6 and for denominator degree of freedom was 6. So 6 divided by 6 is 1. So F test calculation for calculated value for 2 degree of numerator and 6 degree of denominator degree of freedom is 12. And now on to the critical values of Anova table. On the top row you can see degree of freedom of numerator, on the left side you can see degree of freedom of denominator. So I have already marked degree of freedom of numerator is 2 and we have degree of freedom of denominator is 6 and the value corresponding to this 2 is 5.14. So F test critical value for this 2 degree of freedom of numerator and 6 degree of denominator is 5.14.